Hi class, it's Bill Berry back with another Java 2 video. We're in week 8 of our typically 12-week quarter, and today we are starting into looking at another design pattern, the one that we're going to most explore most in depth this quarter. It's the observer design pattern. It is a super interesting one and one that you'll see used in various ways in the world, so it is a worthy one to spend some time on. So let's jump in and learn a little bit about the design pattern, how it's put together, and we'll look at some code. Maybe over 2 videos we'll see how it goes in terms of timing. So first, what is the design pattern? The design pattern, the observer here, is some design pattern that helps objects stay in the know. It helps objects know what's happening elsewhere in the system. It is an information exchange design pattern. So what is an analogy? How can we think about this? Well, first, think about a case where you can go to a company website. Let's say you see an ad somewhere and you click on it and you go to the company's website and they say, please let us keep you informed. Just enter your email and you can press OK and we will subscribe you. So you can subscribe to that content. Then anytime that website, that company has something interesting going on that they think you might want to know about, they will send you an email, right? They will push out information to you saying, here is something new that you are interested in. Now, you have subscribed to this, but you can also unsubscribe. So if you decide, hey, this is too much, it's not the kind of thing that I really wanted, you can always unsubscribe and then it doesn't come to you anymore, right? The subscription will stop for you, but it will continue for others. So if you think of it from the company's perspective, you continually have customers signing up for the newsletter and people dropping off of that subscription list, and that's fine. People are coming and going. That's kind of the whole deal, right? That's the whole point of this thing. So let's look at how the observer pattern is put together. There are two major components that we want to pay attention to here. One is called the subject. The subject is where all of the key stuff happens. The subject is the main guts, the main engine, where the stuff of interest is taking place. On the other side, you have observers, and observers are objects that are interested in paying attention to what's going on in the subject. And as we said before, that group of observers is dynamic. Things can come, things can go. Objects can come into the picture or go out. And then the subject, at whatever period of time makes sense, whenever something interesting has happened, for whatever reason, however, whenever new data, something new has happened that might be of interest to observers, it sends out an update. All the observers get updated and everybody's happy. So over time, you'll see at this point, Jim and Bob, again in our analogy, are subscribers. So the Jim and Bob are both observing what's going on in this subject, whatever it happens to be. Now, what happens over time, Sue might say, hey, I want in, please let me know what's going on here, so register me. So now Sue can sign up and become one of the observers. And therefore, any updates that happen to go from the subject to the observers, all of them are informed. So of course Sue is included in that list. These are all observers. Also note that over time, some observers may decide for whatever reason their displays get turned off. For whatever reason, they just decide, hey, I don't need this information at the moment. At runtime, all this is happening at runtime, they can deregister, right? They can unregister themselves from this thing. So for instance, Jim says, you know what, my users decided they don't want this on their display, or they click the button that says don't show me this, whatever. Jim says, hey, I'm not interested at the moment, so please take me off the list. So then Jim can move out of the list, and of course the list of observers is now smaller, and now only Sue and Bob will get these updates. So it makes perfect sense, right? It sounds like something reasonable, and it turns out that a lot of times when you are creating architectures, sometimes you need this kind of thing, right? You need to have observers that can jump in and jump out and be informed of what's going on in the system. So what's the definition of the observer design pattern? Well, it creates a one-to-many relationship, right? A one-to-many dependency between objects where if something interesting happens, we could call it a state change, right? A significant state change happens in the subject, all of its dependents, which we'll call the observers, are automatically notified. Now, if that sounds a little familiar, that Probably should, right? It should sound a little bit familiar because we've already seen this in action. We didn't necessarily call it observer at the time, but if you think about it, when we learned about Java Swing and event-driven programming, all the listeners that we talked about and created, those are observers. Those listeners are paying attention when something interesting happens. Now, with the GUI, it's something like, oh, the button got clicked, that was interesting, or oh, the slider moved, so maybe they want to listen to that and see exactly what's happened to the slider. But these listeners are indeed observers. So the observer pattern is well in place in creating GUIs and well in place in Java's architecture for this, right? It's built in. So that's kind of cool, right? So we've already seen this working. And if you think about it, we were calling code that would add a listener. And you might have paid attention, and I said you can actually have multiple listeners to one event, and you can have one listener that handles or listens to multiple events that come from a subject as well. So we can add listeners, but on the other side, there's also a remove listener method. So if anybody, for whatever reason, doesn't need that information anymore, they can say, hey, I just don't need to be on the list at the moment. They can come back later, and all of this is done at runtime. In fact, all of this stuff that we're talking about is cool because it happens at runtime and it doesn't require new compiles. You don't have to stop and rerun. So a lot of runtime stuff, and it's pretty amazing to see this all happen. So how does it happen? What is it that we need here? If we wanted to build a system like this, how would we do it? Well, one of the keys here is we need loose coupling. We need to make it where the subject and observer aren't so interdependent that you've got to recompile them all the time. In fact, if the subject has new observers, it should not specifically have to be compiled, right? As we talk down here, we need a no compile solution. So the subject should be able to register new listeners, new observers, and let them go, and there should be no requirement to recompile the subject. It shouldn't really care. So there really needs to be very loose coupling here so that we can reuse these things so that observers can pop in and pop out. That's the ideal here, right? Loose coupling and no compile for the subject. So how would we do that? Is an architecture coming to mind, an idea coming to mind? Do you get the idea that the magic here is going to happen through interfaces? Because interfaces can do some neat things that kind of help us with this, right? So the basic idea here, the basic architecture is going to be we're going to have a subject interface and an observer interface. We'll see why these are so critical, but we are going to treat the relationship between the two types of objects are going to be completely dependent on the fact that they implement these interfaces. That's the only relationship that is important here. Interestingly, the subject might have a whole other set of uses and the observers might have a whole other set of uses and the subject just doesn't care. It doesn't really matter what the observer was designed to do. It only has to play well in this particular context to get the information that you need from the subject. So it, again, very interesting kind of architecture. Subject does what it needs to do. Observers may have a whole other range of activities as long as they do the following. So let's pay attention to what the interface methods are. Now, these methods don't have magic names. These are names that you might see slightly differently in some models. So the names aren't magic, it's just the idea. So the subject must have a way to register an observer. Sometimes you'll hear it called attach or register or whatever. You could call it sign up. So you have to pass in an observer and say, hey, I'm interested, right? Register me. Now, notice though, all that we know about the thing that's coming in is that it is an observer in this system. We don't know anything else about its purpose. We don't know what kind of methods. And remember, when you use this interface, you're using this to get some interesting polymorphism, but it's using these to sort of serve as a collection, right? An observer is going to be one of any objects that happen to come in, but by using that reference, as long as they've implemented it, they can come in, be passed in this way. And that's all we need to know is, hey, they're an observer. So even though they have disparate purposes in life, potentially, we don't care. They just have to implement the observer. Same thing with removing, right? You tell me what observer what needs to be removed and we will remove it. You also need to have some sort of notification method. So you need to have a way that when state changes in some way that's critical, that's important, meaningful to somebody, you have to notify the observers. Now over on the observer side, you really just need to have a way to update the subjects, right? So in this case, the observer has an update method where the subject can call and say, hey, I have an update for you. Sometimes, like you see here, it'll say which subject, because you can have more than a one-to-many. You can actually kind of have a many-to-many thing going on. So in this particular model, it says, hey, I'm going to let you know what subject is talking to you, because if you have a complex model, there might be more than one subject who could be communicating to this observer. So, hey, I have an update for you, and this is the subject that sent that particular update. So these are some of the critical methods that you need to have with the subject and with the observer. Now, once you actually implement that, you're going to need some specific things, like we could certainly use an array list. That would be really easy. And what is the data type of that going to be? It's going to be an array list of observer. Now again, we're using that as a general way to collect anybody that implements the observer interface. Any object that implements the observer interface that we have can participate here. And even though it's very limited what visibility we have in terms of methods, it doesn't matter, because that's the only interaction that we're going to have with them, is the things that can be done with an observer, which is I'm going to be able to send updates to them. That's all that's needed. So maybe we use an array list, and then of course you have to implement the code that does the registration and removal and some way to notify it. So you've got to take, of course, all of these methods that are here and implement them in the concrete, whatever you call this thing that actually is a concrete implementer, right? Code that actually implements that interface. And then over here, same thing with the observer. Of course, you have to actually implement the update, which says when the update comes to you, then you need to do something with it, right? Do whatever else you need, but here's the information. So that's the basics of how you can implement this, and we're going to talk about a couple different ways that information can flow, because sometimes the information will come with the update. It doesn't look like it does here, but that's sometimes the update will contain information, and sometimes you have to make a call to pull that information. So you either have a push, which pushes from notify to update, or sometimes there'll be another call over here, another method where you say, hey, I'm interested, I'll bite, so go get me that information that you have. Now, I'm not going to talk about this one a lot, but I just want to show you this I pulled from the web, and this is an example of a particular system that used an observer, and you can kind of see some of the similar stuff. The wording may change a little bit, but you get the idea. This is a subscription type service, and if you're interested, you take a peek and there's a reference there for you. Okay, so what we'll do is we're going to stop the video at this point because it's getting long enough. We've talked about the basics of what the observer model does, right? The design pattern. What does the observer design pattern do? What are its key elements, key components? And we also talked about looked at an example of how you might implement that using interfaces, and why interfaces are so critical here, because we're actually using that as a data type for the registration, which is what makes all of the stuff magically work together. So in the next video, we're going to start looking at some sample code. I have some code that I've written, and we'll use that, and then we'll look at some other places that you might find more, sort of a different example of this model, and we'll end with some information about how Java provides some support for this inside Java. So thanks for watching this video. Hope you're finding it useful, and we'll hope to see you in the next video.